Okay, a quick couple comments on sampling design. This is going to come up on several of our labs, so we need to hit what makes a sample a valid sample here real briefly, and this shouldn't take too long. And we're going to focus in on camera trapping since that's what we'll be doing in our lab. Before we get started, we need to become familiar with some terms. So a census is when you count every member of the population. So systematically acquiring information about the members of a given population. It's a complete count. Now, what are some problems with this in wildlife research or in any ecological research? The problems are that the odds of you actually counting every individual are slim to none. Therefore, if you assume you have them all, you're probably off. Whereas what we call a survey or a sample, that is a partial count of the whole in which we then can make estimates at what our range of the actual population really is. And I'll come back to that in a minute. So most of the time in wildlife and in ecological research, a sample is actually more accurate than a census. Speaking of accuracy, what is accuracy? That's when you can get as close to the true number as possible. This is a really classic way of looking at accuracy and precision, which we'll talk about next. But think of that bullseye. If you're accurate, you hit the bullseye, right? Well, precision can happen even if you're not accurate. So here we happen to have about 6 or 7 shots that all hit the bullseye. That's pretty precise and accurate. Up here we have those same 6 or 7 shots, and they were close to each other. Although they were not accurate, they were precise. So with precision, you're hitting in the same spot just about every time. Those of you who sight in your rifle, it's that similar idea. If you can have high precision, then you can adjust it to get right on the target as needed and get it accurate as well. Now, down here, we have a fairly high accuracy. They're hitting the target most of the time, but your group is so scattered that we would say it has low precision. And then up here, who knows where you're going to hit. You're just pulling the trigger or shooting the arrow and hitting wherever you get lucky. You might get lucky once and hit the target, but overall you had pretty low accuracy and overall you had pretty poor precision. So the goal with sampling is to get both accuracy and precision. And we're going to show you how we can measure that in a little bit. An index, you might hear of an index. That's a value used in lieu of the actual number, and we might do that because we can make an index based on actual numbers that might make some kind of reporting out be more understandable to the general population, and we can assign like an index score of a certain range is good, an index score of a certain range is very good, or an index score of a certain range is average, etc. Occupancy, we did this with our prairie dogs, right? But that's looking at the proportion of either accommodations or a habitat that is in use by the animal or occupied by that animal. Then we can get an idea of the overall area that is covered by that animal. And distribution, it's looking at where something is, but it's not necessarily looking at the number or the population. So how spread out are individuals in that population, regardless of how many there are. Maybe they're congregated in a higher quality habitat and they don't have an even distribution across the landscape, in which case that might affect how we would choose to sample for that population. Okay, some other things that we've talked about briefly here and there, but we haven't really identified, is a couple different types of sampling with wildlife. We have invasive sampling over here and non-invasive sampling over here. I should write that in, but this is non-invasive. So invasive samplings is just that. You're invading that animal. Most of the time we're capturing trapping of some kind, maybe treeing. Most of the time we're giving them some kind of drug to make them immobile, unresponsive. We're taking blood. We're checking teeth. We're checking age. We're checking bone density. We're checking health. There could be a myriad of things we might check that if we can get our hands on the animal, and that would be invasive sampling. And then in the end, oftentimes we tag them or put a collar on them. Now over here on our non-invasive sampling, this would be things like you read about with the bears in Yellowstone collecting hair from a snare. eDNA, that's a pretty cool up-and-coming thing, is getting environmental DNA. So we slough off our DNA all the time in our skin, in our saliva, in our hair, and so do animals. And so we can sometimes collect part of the environment and actually see what animals have been there. We can collect scat or use scat detection dogs to find scat to see what was in the area and do a scat survey. We can do tracks as well as scat surveys, so we might go out and estimate maybe abundance of animals based on how many tracks were there. And we can actually lure animals to particular stations in order to leave their tracks and do track stations. So these are just a few of some non-invasive sampling methods that we could use. And one that we're going to cover right now and not listed here is using cameras to take pictures of the animals and get information. That way, most of the time they have no idea that their picture was even taken. Oh, there's non-invasive. Okay, so what makes a sample good? Well, a good sample is going to be representative of that larger population so that you can make an inference about the larger population. In order to make an inference, you have to minimize bias. You can't insert your own ideas into the sample. You can't choose to sample one area over another because of ease or convenience. Those would be ways of influencing the outcomes in a way that might make your sample not represent the whole. A quick example of that might be if you were sampling tree species on a mountainside, and so you only sampled near roads so that you didn't have to hike, and you said all the trees near the roads were aspen. Well, maybe the roads followed the riverbeds, and therefore all the trees near the roads were aspen, but surely not all the trees on the mountainside were aspen, and you would have biased your sample by only sampling a certain part of that environment. Minimizing your standard deviation. So here it's that goal of precision. So this is a standard bell curve, and you guys in your homework asking about sheep and some of the statistics they give, I asked what is standard deviation, or what is SD? And what we're looking at is how many standard deviations from the mean is a certain percentage of the population. So a lot of times we call this a confidence interval. So we can go with a 99% confidence interval or a 95% confidence interval. But the idea here is that we can say with confidence that 95% of the population falls between these values, with this being the mean. So say that was I'm not going to have the right numbers, but say this was 100 individuals, that we said there was 100 individuals in the population. That was the average or the mean, and we can say, but we know we're somewhere between 75 and 125 individuals with a certain number of standard deviations. So we could have 75 or we could have 125, and we're 95% sure of that. So the smaller we can get this curve, the more precise that we are getting because our cluster is smaller. And our sampling design might influence then how precise we can get our sample to be. The other thing that can influence that is having an adequate sample size. We tend to think that more is better, right? If we sample a whole lot, then we're likely to come really close to the actual number. But that's not necessarily the case. There's a point in which it's kind of like the law of diminishing returns. If we sample more and more and more, we're not going to get any more precise. We are just going to spend more money sampling. So we need to find the most cost-effective sample size in order to get the results that we're aiming for and not waste our efforts. And these are obviously something you're going to need to take a statistics class and learn a little bit more about, but this gives you an idea for the language that we're using. In wildlife research, a big concern is how detectable can we actually detect that that animal was there. We'll talk a lot about that with our camera trapping. Okay, let's talk about some spatial sampling designs. First of all, we have simple random samples. This is the idea that every member of the population has an equal chance of being sampled. So if I was studying ring-tailed cats here, I might set up a camera at each of these dots, and the computer randomly told me locations. So if I biased it and said I only want to put them down here, but all the cats live up here, I might miss them. So the idea is a random sample is every area in here, and all the cats in there have an equal chance of being caught on camera. Now, these circles that you see is the size of a home range. So by spacing our sample units farther apart than the size of that ringtail cat's home range, then we can definitively say that we didn't sample the same cat twice because our cameras were farther apart than their home range. Therefore, we would say that our sample units, which are these sites, are independent of each other. They're not influencing each other. And we can't always do that, but it's something good to keep in mind. Systematic sampling then, instead of it being random, you might sample every 100 meters along your entire sample area. And again, you decide on how far to space them based on how many sample units you needed to collect, and maybe a minimum distance between each unit in order to keep them independent from each other. And then we have what's called a stratified random sample. This is an important tool to use when your area is not uniform, and so you may end up having maybe, like in this example, more area of woodland than like rangeland. And so if you just randomly sample here, just by chance, you might avoid having any of your samples in the rangeland. And so we're going to stratify and say, okay, we're going to take a certain number of samples out of a woodland, a certain number out of cornfield, a certain out of the soybeans, and a certain out of rangeland. And within those stratifications, we will randomly sample. So that's an important way to make sure that if you have a different strata or different habitat types, that each of them can get sampled. I don't think I need to show, oh, like here, if this was an oak woodland and this was, I don't know, maybe a grassland or something, we might want to actually stratify this to make sure that we get a good sample out of the oak woodland. Okay, a couple different types, techniques for sampling. We have our quadrat sampling, which we'll use quite a bit in our wildlife classes. That's usually looking at habitats. You can make them small, like a quadrat, or you can make them large, like 1/5 of an acre, like you might use in forestry. A transect sample is the idea that you're walking a straight line or you're running some kind of a line, and you're counting individuals within a certain width from that line. A belt transect is kind of a combination of these two, where you run a line and you sample a plot kind of systematically along your transect. And the point intercept is you're running a transect, and maybe every meter you're dropping down and seeing what vegetation you would hit along every meter along that transect. And then some wildlife specific sampling methods. We've already talked about mark recapture, but the idea here is if we know how many individuals we have marked in the population, and we resample, and let's say we caught half of our new sample was marked, we could assume that our first go marked half of the total population. Now, only having one recapture really is not that accurate, and you were to watch a video either this week or last week on how this really works. So if you have questions, then let's talk about it. And the last thing I want to show you is this idea of distance sampling. This is used quite a bit in wildlife management. It's widely used to see what's our abundance of populations, and we're going to base it on some kind of a line transect or maybe a point transect where we are at one certain point and we kind of count in a radius out. or we're driving some kind of a line or walking some kind of a line, and it's anything within sight. So it differs from our line transect in that it's as far out as we can see, but we have to know the distance from where we are to where we spot the animal. Now I'd like you to watch these two videos, which I'll post following my video, that really overview some of these sampling techniques, how we can use them with cameras, and this one in particular gives a great overview of this distance sampling method. But in the end, we need to match the right design with the right techniques to answer the question that we're trying to get at.